Good morning, my dear Aksharians. Yes, very good morning all. Today, let us discuss one very important chapter in our SSLC mathematics. What is that? How it is? What is the use to our education? Let us all discuss these things. Okay? Yes. My dear children, in our daily life, we are using mathematics in plenty of ways. Right? Exactly? Yes, my dear children. Yes, this chapter is also we are using in our daily life from your childhood. Remember it. Okay? For example, my dear children, your father bought some chocolates to you and your brother also. Okay? Yes. He brought 12 chocolates to give you and your brother. Okay? He has given 5 chocolates to you and remaining to your brother. Yes, there is a question. How much chocolate my brother received from the father? This is question arises in your mind. Right? Exactly. Now you start counting. I received 1, 2, 3, 4, 5 chocolates. My father bought 12 chocolates. Remaining is 6, 7, 8, 9, 10, 11, 12. 7 chocolates to my brother. Right? Then your brother received 2 more chocolates than you. Clear? Clear, my dear children? You received 5, your brother received 7. Right? Yes. In some example, for example, your father bought the same 12 chocolates to give you and your brother, but he gave some chocolates to you and remaining to your brother. Remember it, some chocolates to you and remaining to your brother. Some chocolates you don't know how much it is. And remaining to your brother, you don't know and he also don't know how much it is. Right? Don't know how much. This is very important. Don't know means that is unknown value. That is unknown value. You don't know exactly. Then how to calculate these things? Can we represent this situation in mathematical way? Can we represent this verbal statement in algebraical way? Can we represent? Yes, my dear children. Now remember these two examples. I go to first example. Okay. Your father bought 12 chocolates. 12 chocolates to give you and your brother. Right. You received 5 chocolates. 5 chocolates. Your brother received, we don't know how much chocolates. Okay. After counting, you got the answer. But before counting that, we don't know exactly. Don't know means what? That is unknown. Unknown is always represent as X. In our mathematics, it is always represent as X. Or it may represent as Y, Z, A, B, C, any alphabet. Okay. Remember, my dear children, unknown means always represent as alphabet. It may be A, B, C, D, 26 alphabets are there. Among them, you can use any one. I use here only X. Your brother got X chocolates because unknown, I don't know. So, remember, my dear children, 5 chocolates and X chocolates. If I add these two, how much I got? You received 5, I received X. Okay. 5 chocolates plus X chocolates is equal to how much? Yes, very good. That is 12 chocolates. That is 12 because X we don't know. Okay. This X means all remaining chocolates other than 5. Okay. So 5 plus X is equal to 12. Right? Yes. What is this, my dear children? Yes, this is the mathematical representation of the situation. This is the algebraic representation of the situation. Then here we conclude any situation can be expressed as mathematically, can be expressed as algebraically, right? We can represent it as algebraically, right? Then here x is unknown, we call it as variable. Then the total is an equation. Remember it? This is called an equation. What is it? Equation. X is variable. Equation in one variable. Right? Here one variable. No? 5 is constant. 12 is constant. X is variable. Right? So an equation having one variable. Now I come to the second situation, right? Second situation means your father bought 12 chocolates and your father give you some chocolates. Some chocolates means you don't know how much. Don't know means you consider it as a variable, means alphabet A, B, C, D, X, Y, Z, whatever it may be, right? Yes, observe here my dear children. This is the second situation here. Your father bought 12 chocolates, right? You received some means X chocolates, right? Remaining to your brother also received remaining chocolates. Remaining means we don't know how much, whether equal to you or less than you or more than you. We don't know exactly. So you take another variable for that. Remember, this is very important point, my dear children. Always variable, not an x only, not x. It may be x, y, z, depends upon the situation, right? You bought x chocolates, you got, then your brother got y chocolates, because you don't know. If he got as same to you, then only it becomes x. Otherwise it is another variable, right? Yes, here I represent it as x plus y is equal to 12. Can I represent like this? Your chocolates are x and your brother's chocolates are y. So sum of these two is 12 chocolates, right? Remember, observe here, x is unknown, y is also unknown. Both also unknown. There are two unknowns, means two variables. There are two variables. X is one variable and y is another one variable. This is complete one equation. An equation having two variables. An equation having two variables. Remember, my dear children, in first situation we can say the value of x very easily, right? As 5 is here, how much we have to add for this? 7. 5 plus 7 is equal to 12. But here the situation is different. Observe here. If you got one chocolate, your brother receives 11. 11 plus 1, 12. If you receive 2, your brother receives obviously 10 only. 2 plus 10 is equal to 12. If you receive 3, your brother receives 9. 3 plus 9 is 12. Right. If you receive 10, your brother receives 2 only. Right. What is the perfect answer for this situation? We don't know exactly. Whether it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, up to 11. Here 11, 10, 9, 8, 7, 6, so on up to 1. Right? Clear? But then how can we say the perfect answer for this situation? Yes, my dear children, there is a way. That way is clue or hint. What is that hint? We create another situation for that. Create another situation. How to create, sir? It may be, see, for example, you ask your father that how much chocolate you give to my brother? Father says the another situation for this. Yes, my dear children, come here. You are elder than your brother, so I give 2 less than you. See, remember, this is very important. You are elder, so I give 2 less chocolates than you to your brother. Means what? See, you receives X chocolates, your brother receives Y chocolates. Means you receives X, means it is 2 more than your brother. So can I write you receives X? X means this is 2 more than your brother. Your brother receives Y. If you add to this, then you will get X value. Then you will get your chocolates. How much do you have? Clear this is? Yes, you receives 2 more than your brother. Right? So can I represent this situation like this? Yes, this is your chocolate, this is your brother's chocolate. If you add 2 chocolates to your brother's, then you will get yours chocolate. Yes, this is another one equation with 2 variables. Right? This is equation number 1. This is equation number 2. There are 2 equations are there having 2 variables, means pair of equations. This is pair of equation. Remember, my dear children, pair of equations is nothing but the equations are correlated to the one another. This situation and this situation should be correlated. Then only we call it as pair of equations. Right? These are called the pair of equation. Right? Yes, my dear children. Now observe another one very important point, my dear children. Yes, what is the power of this variable? Power, exponent, index, power. Yes, there is no power. Very good, my dear children. There is no power. Means there is 1. If there is no power, means always there will be a 1. Here also there is no power, means 1. Here also there is power 1. Here also there is power 1. If the variable is having power 1, such equations are called linear equations. Remember it carefully, my dear children. What is a linear equation? In an equation, the highest power of the variable should be 1. The highest power of the variable. Here 2 variables are there. 2 variables are also having the highest power is 1 only. That 1 is positive. There should be, remember the point, the 1 power should be positive only. Then only we call it as equation. The power should be positive only. If power is 1, then that is linear equation. Sir, power is 2, then that is quadratic equation. If the power is 3, then that is cubic equation. Like this, so on. If the power is 4, fourth degree equation. Remember this word, my dear children. We call power as degree also. Okay? Yes. Okay. My dear children, now come here. There are 2 equations having 2 variables. Having highest power is 1, means linear equation. We call it as pair of linear equations in 2 variables. This is the chapter we are going to discuss in this class. Okay? Yes, let us come to the another one example, my dear children. Whether they are linear equations or they are another type of equations or they are pair or not. Now tell me. Okay? I will give an example to you. In a company or a factory, an employee name as A, another one employee there is name as B. Okay? Yes, the both are receiving the salary. The sum of that 2 employees' salary is 15,000. So remember here, my dear children, here is employee A and employee B. Sum of these 2 employees' salary is 15,000. Sum of these 2. I don't know exactly. He is taking 10,000, he is taking 5,000, or he is taking 5 or he is taking 10. I don't know exactly what they are receiving. Okay, my dear children. Is this equation? Yes. Is it equation, linear equation? Yes, because A is having power 1 only, B is having also power 1 only. Then this is linear equation. Equation as well as linear equation, and we don't know exactly how much salary A receives and how much salary B receives, we don't know. Then that is variables. Right? Can we solve this equation alone? No, we can't solve the equation alone. If we solve the equation alone, we won't get perfect value. Exact value we don't get. Right? So what we need here? Another situation related to this only. Yes, the another situation is like this. A receives twice as B's salary. Remember it. A receives twice as B's salary. Twice as B. Twice B. Can I write like this? A receives twice as B. Twice as B. Remember it, the word twice, thrice, 4 times, 5 times, 6 times. Times means product, multiplication, right? Okay, yes, twice as B. Can I call it as an equation? Yes, this is another one equation related to the same situation. Then we call it as pair of linear equation. See, my dear children, I express this equation as A 2 into B means 2B. Transfer this, it will become minus 2B, which is equal to 0. This is another one equation having variable A and B. Here one equation having variable A and B. These two are called as pair of linear equation in two variables. Pair of linear means power. When the word linear says the power should be 1, it means, my dear children, if you represent this equation graphically by using graph sheet, you will get straight line. You will get straight line. So we call it as linear equation. Okay, my dear children. Linear means power should be 1. The power of the variable should be 1. And if you represent the equation or solve the equation by using graph, then we get straight line. So we call it as linear equation. This situation also gives us the pair of linear equation in two variables. Then shall we move on to the chapter? Now you got the name of the chapter. What is that? Exactly, my dear children, pair of linear equation in two variables. That is the name of the chapter. Let us we continue this chapter. Okay? Yes. Which is that chapter? Pair of linear equations in two variables. This is the third chapter in your textbook. Okay, my dear children, very important chapter for your examination, and this is very important chapter for your daily life also. Before only I told you, my dear children, from childhood you are using this equation, solving these equations. You solved plenty of problems. So it is very easiest chapter to you, my dear children. Pair of linear equations in two variables. Understood? Yes. Now let us come to the chapter pair of linear equations in two variables. Right? Yes. In the introduction class, we discussed about equations, linear equations and pair of linear equations and variables also. Right? Yes. For example, x plus y which is equal to 10 and 2x plus 3y which is equal to 50. Are these two pair of linear equation in two variables? Exactly. X and y are two variables having the power 1, therefore linear equations. In the same way here also x and y are two variables having the power 1, therefore these two are pair of linear equations. Right? Yes. For example, my dear children, if I take z as a variable in second equation, now tell me, are these two pair of linear equation in two variables? Observe, think, say my dear children, x plus y equals 10, x and y are two variables and this is a linear equation, right? X and z are two variables and this is also a linear equation, but these two are not pair because in the first equation the variable is y, in the second equation the variable is z. See, if we said pair means it should depends on other. The equation depends on this or this equation depends on that. Then only we call it as pair. Otherwise, they are linear equation in two variables. That's it. Okay. Express this as an equation. Express the situation as an equation. For example, my age is twice as old as your age. My age is twice as old as your age. Right? This is situation number 1. My age. How much is my age? Twice as old as you. Yes, that is your age. Your age. Consider your age as x. Then my age becomes 2x. Because the statement itself says my age is twice as old as you. Your age is x, then my age becomes 2x. If your age is 10, then my age is definitely 20. If your age is 30, then my age will be 60. Right? Yes, in the same way, your age is x and my age will be 2x. Right? Okay? Yes. Now, another continued statement. The sum of we both the ages is, the sum of both the ages is 60. Is 60. Sum of both ages, sum of both ages is 60. Therefore, 2x plus x is equal to 60. Then 2x plus x is 3x, then you will definitely get the answer for x. Right. Now tell me, is it linear equation in two variables? Is it linear equation in two variables? Yes, listen here. Yes sir, this is linear equation, but there are no two variables. Here x is only the one variable. X is only the one variable, right? So 2x plus x means 3x, which is equal to 60. X is one variable. This is not a two variable equation. Two variable means two different unknowns, X, Y or X, Z or A, B, M, N, like this, so on, right? Two variables means they should be different unknowns, right? Yes, according to this situation, this is the obtained equation, but this is a linear equation, but not in two variables, right? Clear, my dear children? Yes. Now observe here. So now there is a standard form or general form for linear equation in two variable. What is that? Observe here, ax plus by plus c, which is equal to 0. Ax plus by plus c equals 0. Observe here, a and b are coefficients. A and B are coefficients, means numerical coefficients. There should be numbers. It may be positive number, negative number, whatever it is, right? So A and B are coefficients and X and Y are variables. X and Y are variables. How many variables are there? Two variables. And C is constant. C is constant. C is constant. See, A and B are coefficients, X and Y are variables, C is a constant. Now, A and B are coefficient means numerical coefficient, there should be number, right? X and Y are variables means different unknown variables. X is different, Y is different. It may be positive, negative, whatever it is. And C is constant means that is also a number. Remember it carefully, right? This is the standard form or general form of linear equation in two variable, right? Yes. Then pair of linear equation means, what is the general form for that? Yes. Observe here. There is a general form a1x plus b1y plus c1, which is equal to 0, a2x plus b2y plus c2 equals 0, right? Here observe here, my dear children, a1 means numerical coefficient, b1 that is also numerical coefficient of y, c1 is the constant of this equation. So we have taken a2, b2 and c2. a2 is the numerical coefficient of x, b2 is the numerical coefficient of y, and c2 is the constant value of this particular equation, right, my dear children? Yes, observe here also x and y are the variable, x and y are the variables. Variables should be same in the both equation, then only we call it as a pair of linear equation in two variables, right? Yes, a1, b1, c1, a2, b2, c2. a1, b1 and a2, b2 are the numerical coefficients of x and y respectively. c1, c2 are the constant values of that particular equations. These two equations are the standard form of pair of linear equations in two variables, right? Yes, continued statement like this, my dear children. In these two statements or in these statements, A and B both should not 0. A and B both should not 0. Both should not 0. A and B both should not 0. Remember it, my dear children. Sir, what happens if A is 0 or B is 0? Yes, observe here. Consider this equation. I am considering this equation. Ax plus by plus c equals 0. If A becomes 0, this is 0 into x plus by plus c is equal to 0. 0 into anything is 0. The remaining is by plus c equals 0. Now observe this equation. How many variables are there? There is only one variable, that is y, right? But the heading is, it should contains two variables. See, now the equation is having only one variable, so this is a linear equation, right? Okay, I agree, but the linear equation having only one variable, right? Okay, my dear children, yes. A and B both should not 0. Okay, if B becomes 0, then only Ax plus C is equal to 0 will remains. There also Y terminates from that. Okay, right? There also, that is linear equation but in one variable. Therefore, this is the condition. A and B both should not 0. Both should not 0. Okay, my dear children. If one zeros, we can agree. It is also a linear equation. If both zeros, for example, you take 0x plus 0 into y plus c equals 0. 0 into x is 0. 0 into y is 0, then the remaining is c equals 0. Say constant value, it is a number, c is nothing but any number, it may be positive or negative. Any number can be equal to 0? No chance. Any number, positive, negative, root, rational, irrational, real, whatever it is, that number can't be equal to 0. That's why we are telling here A and B both should not be 0. Right? If one is 0, we can agree. Yes, this is a linear equation. If both becomes 0, we can't agree because constant becomes equal to 0. So it not happens anywhere. Right? Okay, my dear children. Yes, A and B both should not 0 means if A becomes 0, B remains. If B becomes 0, A remains. Then we agree that then we calculate the values of variables. But if A and B both become 0, then we won't get the equation, we won't get the values of the variable, we get only the constant equals 0. It will not happen anywhere. Right? Clear, my dear children? Here you remember A and B are the coefficients, means numerical coefficients. A and B should be numbers. X and Y are the variables. C is the constant. So A1x plus B1y plus C1 equals 0 and A2x plus B2y plus C2 equals 0. These two are the pair of linear equation in two variables. This is the general form of linear equation in two variable. These two are the general form of pair of linear equation in two variables. The condition is A and B both should not 0. Okay, my dear children, agree with this? Yes.